that special thing you use to take your nuts off, and they just fall off?
You use a Dremel and like grind them off. Okay, so Taylor was good starting this. Okay, except for the, I can't erase those without doing the whole thing. So I'm just gonna start over. But we would replace that cosecant with 1 over sine. So get it all in terms of sine or cosine.
But why is the second one sine? Because I got the first part right, but then the...
Because cosecant equals sine, 1 over sine.
Right.
So,
I see.
So at this point, we can't like rewrite anything. We've got everything broken down as far as we can. But what we can do is multiply the sine through there.
Oh, I'm so
Distributive property. So sine times 1 over sine would be sine over sine, which is 1. Minus sine times sine is sine squared. And if we recall back up here, just like sine squared is equal to 1 minus cosine squared,
So it equals cosine squared.
1 minus sine squared would be cosine squared.
I got you. That makes sense.
Ta-da!
So that's what happened.
And it takes a lot of practice to do this stuff. But the main, I guess the main thing that you need to do is just start somewhere. Like you guys have a tendency to want to try to map it out in your head, like this is what I'm going to do and then I'll do this and like try it out.
Just try
Just jump in and do it. Don't
Don't test the
overthink
waters,
it.
Just like,
Don't overthink it. Just try something. And if it's not panning out, start over. Like it's okay to get it wrong at first and then try something else. I don't expect you to get these all your first go around. Okay? This is practice. We're learning. We're not all going to do the same thing in the same order and get the same answer. And that's okay.
the answer wrong.
We want to go back and try again. Don't be afraid to try something and fail. Okay? It's okay to be a stupid disappointment on these at first.
okay.
It's okay to feel like that. I'm not saying you guys are stupid disappointments, but I know you feel like you're stupid disappointments sometimes when you don't get it right away. But that's okay. We don't necessarily have to get it right away. Plug stuff in, see what happens. If what happens was not what we wanted, then you just do it again. And that's okay.
Are you gonna give us the answers?
No.
Dang.
So the other way that the problems will be presented is like this, where it's going to tell you, like, here's the expression, rewrite it in terms of sine. So that doesn't necessarily mean that we need to get it down to a single term or a single number, but we do want to try to simplify as much as we can. And we want to rewrite it so that if there are multiple instances or multiple terms, that the only trigonometric functions in there are sine. Is sine or sine? I don't know. We're going to plug sine in where we can. So we're still going to start out with the same kind of process as we did on the other ones where we're simplifying. We're going to try to rewrite everything either in terms of sine or cosine. Or look at different identities that can help us like eliminate terms or get them all into the same thing. So on here though, there's a lot of different ways that we could start this. And if we want to turn this into sine or cosine, or sine, I would say start with our reciprocal identity, or the quotient identities. So tangent and cotangent can both be written in terms of just sine and cosine.
Oh,
So cotangent squared is cosine over sine. So cosine squared over sine squared. Minus tangent squared would be sine squared over cosine squared.
But those just, no, those wouldn't cancel out.
If they were multiplying, then they would be 1. But if we're subtracting, okay, we want to get rid of the cosine squareds because we want this all in terms of just sine.
oh, wait. Wait. They would
It's
all
not that
cancel.
easy. They don't all cancel out.
Oh, so see that makes
I know you got real excited about that for a sec. So when we are simplifying these, I might be making this more complicated, but we'll get there in the end. We have these two fractions. We can't subtract them because they don't have common denominators.
Yeah.
In order to get them to be common denominators, we
Sine over one.
we would multiply each of them by the other denominator on the top and bottom. So if I want to get, our common denominator is going to be sine squared times cosine squared. It's the combination of those two. So to get that, we're going to multiply the one on the left by cosine squared over cosine squared. And the one on the right by sine squared over sine squared. This will be interesting. There's some factoring involved here.
Okay.
So, what we've got here is cosine squared times cosine squared would be cosine to the fourth. Minus sine squared times sine squared would be sine to the fourth. Over cosine squared sine squared.
Doesn't that just leave us back with cosine squared minus sine squared?
No, not yet. So, yeah, we can factor the top.
So,
Okay, so that cosine to the fourth minus sine to the fourth. If we think of this as terms like x to the fourth minus y to the fourth. This is a difference of squares. This can get factored as x squared plus y squared times x squared minus y squared. But instead of x and y, we would have sine and cosine. So this is going to be cosine squared plus sine squared times cosine squared minus sine squared over cosine squared sine squared. We're going to deal with that in a minute. Huh. What?
So you did it wrong.
No.
what?
That's our answer?
No. Because it's not all in terms of sine.
Is it in terms of tangent?
Cosine squared plus sine squared.
Wait, one more time?
Cosine squared plus sine squared.
Just cosine squared, sine squared. Oh, I see what you're saying.
It equals 1.
Oh, wow.
So this whole thing right here is 1.
And so the thing is there's one too.
So this is just
Why not?
1. 1 times cosine squared minus sine squared is
Just
cosine squared minus sine squared.
so they do all cancel out.
Nope. If that was multiplication on the top, they would. We're not done yet.
Wait. Stop.
Okay, so at this point, we can replace the cosine squareds with something in terms of sine. Because from previous problems, we know that cosine squared is the same as
Sine squared.
1 minus sine squared.
So we would just. No. Wait, what did we do last time? Wait, we should.
So just replacing each of those cosine squareds with 1 minus sine squared. We have this whole thing in terms of sine now. It is pretty gross. But we can combine some terms here. We can combine like terms. Simplify it a tiny bit. It's not going to be a ton better, but it'll look a little bit nicer. On the top, if I have 1 minus sine squared, that's going to be 1 minus 2 sine squared over 1 minus sine squared times sine squared. You would have to distribute that through there. Oh, goodness sakes. Oh, that's not. Never mind. Like, if we can factor this again, I'm going to give up. There we go. Doesn't that look so much better? No, it doesn't. Cotangent squared minus tangent squared. That looks a lot more concise than 1 minus 2 sine squared over sine squared minus sine to the fourth. This part is not necessarily about, like, let's make it look better. It's just manipulate this how I asked you to do it and see what happens.
Oh gosh, this is terrible.
It's like training to be a Russian spy.
Yeah, that's how it feels like.
This
This feels like trying to be a toxic boyfriend 1.0.
Feels like trying to be a Jamaican spy at this point. It's
Jamaica's not well known for their spy program.
exactly.
Okay.
That's why.
So, on the homework, I think the 21 through 26 is like the first ones that we did, where you are just simplifying it down to an individual thing. Let me double check before I commit to that.
My head hurts so much.
Oh my gosh, I quit eating coffee this weekend. And I didn't quit, I just forgot and slept all day. But
Pretty much forgetting.
Yeah, I like, didn't even realize it until later. Oh my gosh.
You drink coffee every day?
Yeah, every single day.
Okay, so 21 to 26 are, yeah, simplify. So that's just like the examples on the first page of this. And then, oh, so 28 to 33. So what's 38 to 41? They're all just simplify. Huh,
Out of 38 to 41, just choose one.
yeah.
Are those the big bad ones?
Mm-hmm.
Great. Is it like these? Like the one we just did?
No, they are using the co-function formulas. Which we didn't do any examples of that, but they are on your sheet at the bottom.
These
Right.
notes look disgusting. I was kind of proud these names came
Great, I love it.
Okay, so, yeah, all of these, you're just, I guess they do have a couple co-function ones on there. But I didn't do any examples of.
I really hope they're not busy.
But if we see like on 22, it has like cosine of pi over 2 minus theta cotangent. Okay, if you see this, that is a cofunction identity. So looking at our identity sheets, the cosine of pi over 2 minus theta is the same as sine. So this whole thing right here is just sine of theta times the, cotangent of theta, and then you continue simplifying that. Okay, so the ones in this section that you're going to use from your sheet are going to be your tangent and cotangent identities, the reciprocal identities, Pythagorean identities, cofunctions, and potentially the negative, even odd formulas.
So this whole entire page, basically.
You do have some that are even odd. We haven't done like periodic or half angle, sum and difference, product sum.
So you said tangent, cotangent.
So the first 4
Okay.
in the first column, and then that bottom right column.
Yep.
So, good luck.
Did you use the ugly?
I can't see that far, but no.
Okay, thank you.
Can you read that green?